Let us now take the fifth model from averages, where the question is based on discrepancy in one of the values while finding out the average. Let us take an example. The question here is average temperature for a week is noted as 32 degrees. But later it was realized that Friday's temperature reading was taken as 30 degrees instead of 16 degrees. So what is the correct average temperature for the week? So as you can see here, the average temperature of a week was calculated as 32 degrees. But later it was discovered that one of the values was taken as 30, whereas the actual value was 16. So from this data, we are supposed to find out what should be the correct average temperature for the given week. Now very clearly, the average which has been calculated, that is 32 degrees centigrade, is the wrong average, right? So we can say that the wrong average which has been calculated is equal to 32 degrees centigrade. Now from this we can say that the wrong total of all the values should be equal to 32 into 7, as there are 7 days in a week. So 32 into 7 will give you the total of all the temperatures for that week, and 32 into 7 is equal to 224. Now from this wrong total, let us first find out what should be the correct total. The correct total of all the temperatures, or the correct sum of all the temperatures, should be equal to the wrong total, that is 224. From this we should subtract the value 30 and add the value 16, because we know that 30 is a part of 224. So we should subtract this 30 and add the correct value, that is nothing but 16. So 224 minus 30 plus 16 will be equal to 210. That means the correct total for the whole week is equal to 210. And from this correct total, we can now say that the correct average should be equal to nothing but the correct total divided by the number of elements. So correct total is 210 divided by, we have 7 days in a week, so that is 30 degrees centigrade. So we can say that the correct average of the week should be equal to 30 degrees. But friends, solving the question in this way will take a lot of time, as it involves 3 to 4 steps. So let us understand how can we solve this question without writing these steps in just one single step. From the given question, we know that Friday's temperature reading was taken as 30 degrees instead of 16 degrees. So very clearly, Friday's actual temperature is 16, but it was taken as 30 degrees. So the difference between these two values is 14 degrees. So that means while calculating the average, 14 degrees was added extra in the total. So that is the reason we have got a wrong average. And this wrong average is higher than the correct average. So to find out the correct average, we need to decrease the overall temperature by 14 degrees. So we can say that the correct average should be equal to the wrong average, that is 32 degrees minus something. Why we are subtracting something here? Because we know that the correct average should be lesser than the wrong average. So 32 minus, the difference is to be subtracted. But very clearly we have discussed that whenever we add or subtract something, it should be equally divided among all the elements. So this 14 degrees should be divided equally among all the 7 days, and then the reading is to be subtracted. So we can say that the correct average should be 32 minus 14 divided by 7, as this 14 degrees is to be equally distributed among all the 7 days. So 14 by 7 is equal to 2. So we can say that the correct average is 32 minus 2, which is equals to 30 degrees centigrade. So the correct average will be equal to wrong average minus the difference of the values divided by the number of elements. Similarly, suppose one of the readings is taken lesser than the actual value. In that case, the wrong average which is calculated is lesser than the correct average. So to find out the correct average, we need to add the difference. So in that case, we should take plus instead of minus. Let us now take another example based on the model that we have just discussed. The question here is, the average weight of a group of 50 girls was calculated as 58 kgs. It was later discovered that the weight of one of the girls was read as 45 kg, whereas our actual weight was 65 kg. So what is the actual average of the group? So as you can see here, there are total 50 girls in the group and their average was calculated as 58 kgs. But later it was found that for one of the girls whose weight was 65 kg, the reading was taken as 45. That means while finding out the average, weight of one of the girls was taken as 45 instead of 65. So we can see that the difference of 45 and 65 here is 20 kgs. Now as you can see here, the difference between the actual weight and the wrong weight is 20 kgs. And while calculating the average, the weight of the girl was taken as 45 instead of 65. That means her weight was reduced. So that is the reason we have got a reduced average. The actual average should be more than the wrong average. So we can say that the correct average should be more than the wrong average, that is 58. And since it is to be more, we should add something. What should we add here? We should add these 20 kgs. But before adding 20 kgs to the average, it should be distributed equally among all the persons in the group. Why? Because average is always an equal distribution calculation. So this 20 should be divided among all the 50 girls in the group. So we can say that the correct average will be 58 plus 20 by 50 will be 0.4. So that is equal to 58.4 kgs. So friends, this is how you can solve these type of questions, simply by taking the wrong average plus the difference divided by number of elements. We should take plus when the correct average should be more, and we should take minus when the correct average should be less. So the answer for this question is 58.4 kgs. So avoid writing all the steps and simply get the answer by taking the wrong average plus or minus the difference divided by the number of elements.